I've never seen an Aldol in the flesh. Reactions, there are 3 in this section. And we'll start with addition. You'll use 1 molecule for each reactant, and then you add the sodium hydroxide or another strong base. Condensations, add in some extra heat, and the heat will make it lose some water. But sometimes it's like different reactants, each make an enolate, multiple products, that's a mixed reaction. Here are facts about aldol chemistry. How do we create aldols?
Aldols.
It'll react in our flask, cause alcohol just ain't for us. Add aldehyde and it's a plus. Comes from an enolate.
Enolate.
You can call it transition state, becomes an aldol.
Aldol.
Alpha carbon chemistry.
An aldol is a molecule that contains an alcohol group as well as an aldehyde. The prefix al comes from the aldehyde portion, and the suffix ol comes from the alcohol. There are 3 types of aldol reactions that we'll cover: aldol additions, aldol condensations, and mixed aldol reactions. First, we'll show you the general reactants and products involved in an aldol addition. It starts with the aldehyde. Often, 2 molecules of the same aldehyde will react with one another. After adding a base, the aldehyde molecules will react to form an alkoxide. This alkoxide is protonated by water and becomes an aldol, which is shown in the products. As you can see, part of the molecule comes from one of the aldehyde molecules, and one part comes from the other molecule. How does this happen? An aldol reaction is special because one aldehyde will act as the nucleophile, and the other will act as the electrophile. How does this work? The aldehyde's alpha carbon has 2 hydrogens. These are readily deprotonated when base, such as sodium hydroxide, is added. This creates a carbon ion with the negative charge on the alpha carbon. This is called an enolate, and when another aldehyde molecule enters, the enolate will act as a nucleophile towards the second carbonyl. Aldol condensations, the second kind of aldol reaction, are similar to aldol additions. In fact, the same reactants are used. The difference is that heat is added. The molecule shown is the product of an aldol addition. In the presence of heat, a base comes in and deprotonates the alpha carbon. This creates an enolate intermediate. The electrons on the negatively charged carbon will form a carbon-carbon pi bond, forcing the carbonyl's electrons onto oxygen. This creates an unstable intermediate, and oxygen's electrons return to form the carbonyl, forcing the pi bond to move to the next carbon, which makes the hydroxyl group act as a leaving group. This results in the loss of 1 water molecule in the form of 2 hydrogens and 1 oxygen. The product can be an enal, which is an alkene aldehyde, or an enone, which is an alkene ketone. The product shown is an enone. What happens when you have 2 different reactants that both form an enolate? Here you see ethanal and propanal. Sometimes 2 molecules of propanal will react. Other times, 2 molecules of ethanal will react. The 2 molecules could also react with each other, but since there are 2 possible enolates, this creates 2 different products. As you can see, one reaction can have many different products, and that's why this reaction is called a mixed or crossed aldol addition. In order to make sure that only one product is formed when 2 molecules react, aldol reactions must be controlled by choosing reactants with only one possible enolate.
Aldols are often seen in biological systems, such as in transition states of the citric acid cycle. A retroaldol reaction, which is the reverse of an aldol condensation, is used in glycolysis to split fructose 1,6-biphosphate into 2 3-carbon sugars.
In this synthesis problem, we are trying to go from an aldehyde to a saturated alcohol. We can do that by first putting in base with the aldehyde to make an aldol. And then we can add in either acid or a base to make an alpha beta unsaturated aldehyde. And from here, you have two options to get to your saturated alcohol. You can either go through an aldehyde by putting in H2 and PD, and then putting in NaBH4 to get to the saturated alcohol. Or you can go straight from the alpha beta unsaturated aldehyde to the saturated alcohol by putting in H2 and nickel.
For this synthesis problem, we're going to need to go from this bicyclic compound with two 6-membered rings to this bicyclic compound with one 5-membered ring, so we're going to have to start off by cutting this ring. We're going to start with an elimination of the chlorine. Now we can ozonalize this double bond. Now, if we add sodium hydroxide and heat, an aldol condensation will occur.